All right, let's do practice problem 12 on page 231. Here's the problem. It says your car has stalled and you need to push it. You notice as the car gets going, you need less and less force to keep it going. Suppose that for the first 15 meters, your force decreased at a constant rate from 210 newtons to 40 newtons. How much work did you do on the car? Draw a force versus displacement graph to represent the work done during this period. So here's what's given. At first, at x equals 0, the force you were applying was 210 newtons. And then at x equals 15 meters, the force you were applying was down to 40 newtons, right? And we want to know, it says you want to know how much work was done, and you want a force versus position graph to actually figure that out. So let's solve it. So here's the graph. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5, 10, 15. This is the position in meters. Now the force goes all the way from 40 to 210. So I'll go 50, 100, 150, 200. So it starts off going at 210, which would be right about there. And then at 15, it goes at 15 meters, it's down to 40. So if you were to graph this, it would look like this. So that's what the graph needs to look like. Some of you took it all the way to the end. If you did, that's fine. But as long as at 15 meters, it's at 40 newtons. Oh, this is force in newtons. Don't forget to label your axes. And so now the work done is equal to the area underneath this graph. That's what this was testing. Now there's a couple ways of figuring out that area. I'm going to do it this way. I'm going to break it up into a triangle and a rectangle. So let's figure out what the rectangle is. So that's base times height, and then we're going to add to it the triangle above it, 1/2 base times height for the triangle, different heights though. So for the rectangle, the base is 15 meters, and the height is 40 newtons. And then plus for the triangle, 1/2 the base again is 15 meters. But the height is not from here to here. Well, it's 50, 100, 150 plus 10 plus 10. That's 170 newtons. So you had to kind of finesse that by noticing that this triangle from, if you go 210 newtons, if you say 210 newtons minus 40 newtons, you get 170 newtons. So that's the height of that triangle. And so, see, 4 times 15, that's 60, plus a 0, that's 600. A newton times a meter is a joule. Plus, and I can't do that in my head, so I'm going to go with the calculator, 170 times 15 divided by 2 equals, and that's 1,275 joules. A newton times a meter is a joule. So that's 1,875 joules. That's how much work was done to push that car through 15 meters. There's another way of doing it. You could, some people did it this way, which was, oops. They said, hey, this is a trapezoid. So it's on its side. So you can say the average base times the height. If you turn this on the side, this base is 210 newtons. This base is 40 newtons. So the average base would be 210 newtons plus 40 newtons divided by 2. That gives you the average base times the height is 15 meters. So if you do this, well, 210 newtons plus 40, that's 250 newtons. 250 divided by 2 is 125 times 15. That gives you the same answer, 1,875 joules. So either way, you just, but hey, a couple of you, I dinged you because you're not showing your work enough. I think you figured out the area, but you're not writing down what it is you're doing. Always on a quiz or a test, always write down what you did. Always write down what you entered in your calculator and make it easy to follow. It's too easy in a, during a homework quiz or something like that, just for somebody just to look over and see what the answer is and put a box around it. I need to see how you get to that answer to make sure that I know what you're thinking and so on. Okay, so what's the big idea here? The big idea is if you have a force that varies with position, you can figure out how much work is done by that force by calculating the area underneath that graph. And that's what we did here. So any questions? That is all. Nice. Nice. Oh, that was abdomen. It was late.